My name is Ottmar, and I'm from Bayer, and I did some testing just around the same topic that Earl just presented, and I thought it might be beneficial for you to get some insight on that. So what I want to talk about is, first thing, iRODS usage at Bayer. So today the short story of iRODS at our company. Then our situation and why we did an proof of concept with object storage. And last but not least, some suggestions how to improve the relationship between iRODS and object storage. Good. Yeah, so iRODS at Bayer was introduced in 2014 in the event of a big project around life science, and it has been developed as an internal data platform for exchanging and managing data around the genomics area in a secure and reliable way. So there are a lot of laws, especially in Germany, how to deal with genomic data, and we found that iRODS was a good fit for that. We integrated that in our specific environment, and we will keep it on our list, though it was identified as key enabler for a future project in that area. And what we also did newly here is to set up a team that is not consisting only of software engineers and people working in that area, also putting some infrastructure guys in, since iRODS is also a topic that is closely related to infrastructure, as you perhaps know. So in 2016, we also joined the consortium, and currently it's used by certain projects. So it started all over in bioinformatics, and is shortly followed by biomarker. That's a different project, and they will have their own systems, and they also have a GXP focus, and we don't want to blame our bioinformatics early research people with that stuff. And also upcoming now is digital farming, which use iRODS for placing phenotype data and also satellite pictures in there. And other projects also think of using iRODS. There's some sort of picture. On the left hand you see some integrations that we did here in our scientific environment. So HPC users are able to access transparently iRODS just using iCommands. We also have some sort of hard disk import-export service from sequencing providers. We also have in-house sequencing and wrote jobs that take the data and move it over to iRODS. And yeah, last but not least, we convinced Gene Data with some money to integrate iRODS into their product. So in Gene Data Profiler, you are now able to see iRODS as just each other source of data, and you can select the data that you are interested in and are able to see. And what we also did is some metadata validation application. So we have, let's say, certain rules that stick to the metadata. So if one attribute is set, another does not need to be set, or something like that, and to provide our scientists who are in charge for curation of the data some sort of methodology they can use to be sure to follow the rules. On the right hand, the integrations that we need to do in our company IT, so just integrated into the identity and access management to provide the audit trail to the people who are interested in that, and also the usage of file system object storage, and also to open up the metadata for the people that are interested. Now, if we had a look at our beginning with iRODS, I call it setup 1.0. that was just as any traditional server in our data center. We had an iCAD and an iRODS server just as VMs with SAN storage attached to that, and it worked. So that was a good message. But then our mad scientists came up with NTS, and I'm more or less an infrastructure guy. I don't really know what that is, but I know what it means. It's 300 gigabytes per individual. So they have studies where 1,000 individuals take part, and just for the math, it's 1 petabyte with just one study. And they are planning even more. That's what they told us. So therefore, the question came up, does it really scale that way at petabytes? And the answer is simply no, it doesn't scale. And that's why, first of all, cost. So if you add up the SAN storage that you would have to provide, and then put backup on top of that, and then add a DR copy, then you find out it works, but you find nobody who is willing to pay for that. And also recovery is an issue, because how do I reword a user or system error that is hitting the whole system? If I do a restore on petabyte scale, I need a lot of time to do that. Okay. And that was a moment where we sat back and thought about that, how we would petabyte scale solution look like. And of course it should be highly scalable. And the second topic was also the price. It should be significantly lower price than our current solution, consisting of SAN plus backup. To reach that, it needs to be fully automated. It should be a no administrative touch system, or at least a very less system. The backup topic itself should not be separated from that. It should be included in the design of the solution. And the same is true for disaster recovery. And Earl just mentioned that data security at petabyte scale is also an issue. So if you have 10 spinning disks, then the likelihood of failing one is quite low, but if you have hundreds or thousands, then it's normal that a disk is failing. So therefore, you need some data security features like checkpoint, self-healing, and so on. And then this will be provided by our storage guys. We want to have a client with vendor support, no DIY. They did not like that. They wanted to have a client. And therefore, we had a discussion on the interface, but S3 has established itself more or less as a standard, and therefore we thought if we want to use something, then it should have an S3 interface, and last but not least, it should provide the performance that we require. And you will be not very astonished, we came across object storage, and I convinced my managers to invest in a proof of concept for that. And the question was, how does iRODS really deal with object storage with S3 interface? And so what we did is we set up just 2 servers, one iCAD and one restore server, and connected 2 different storage solutions from 2 different vendors to that, and had dedicated file systems acting as caching device. And we started with iRODS 4.0.3. We had to do some cheating with the S3 resource plugin to get it compiled and so on. And later on, there was also a requirement to use 4.1.8, and that meant during our tests that we had to upgrade our iRODS version to the recent one to be in the testing matrix that iRODS is supporting. So, yeah, the integration of iRODS, Earl already mentioned it. It's implemented as a compound resource. That means that every write is going to the cache, and from the cache to the archive, and the read vice versa. So since there is no direct access to that archive layer, an additional cache file system has to be provided, and that, as mentioned before, is on a dedicated resource server, and those storage solutions were connected to the same server, so that we had the same starting point for our performance tests and also for functionality tests. So yeah, the findings in that area, obviously the caching tier doesn't come for free, so you need some sort of housekeeping around in that. You need a rule that is taking care that the replication is happening, and you also need some monitoring that if something fails, that you reset the replication and something like that. And you also need to take care that the cache is not filling up to its rim, so that it's trimmed in certain time periods, and also that this trimming is supported by some I commands like output or I get, but not all commands really support that. That might be a future request to enhance some I commands if we stay really at that model of compound resource, that they are able to clear the cache after they have been executed. Good. Here is an example of the arguments or the parameters that are available if you configure the S3 connector. There are more to come in the upcoming version, thanks to Earl. He, I think, doubled the number of parameters that can be... Sorry? But I think it's all beneficial that what he did. So all tests were done with a plugin version 1.3, and what needs to be considered is that it relies on libs3 and libcurl, and that's important because libs3 is providing the base functionality for the S3 plugin, and if libs3 is not able to do something, then iRODS won't be there. And another important thing that in our test object version was enabled, but you remember that I told that backup should be part of the solution itself, and that's where object versioning comes into play. And that's just doing backup, but obviously if someone wants to do a restore of older versions, then some sort of custom script is needed to reword old versions to a level of version that you would like to have. And at the bottom there is just an example of how to register an S3 archive interface with the parameters that we use. So during our proof of concept, we came across certain issues. So load balancing itself was somehow tricky. Now, connecting S3, or let's say the performance that S3 is providing, is received during parallel operations. And that's the reason why you need to put a load balancer in front of that. And the load balancer itself takes care that it's balanced over all really available network interfaces. And what we found out is that with that version of the S3 connector, the bulk transfer option did not really work out. So it just was using one single connection for whatever reason, and therefore our feeling was that multiple output requests were quite faster than just using output with Spark. That was quite strange, but I think that's related to how it was how the layout was at that point in time. Then the next hurdle that we came across was when we defined the multiple endpoints, it looked like that the configuration was not properly set up in the code, and so it looks like when we connected to the first, it was using the credential of the second, and so on. And that was an issue that we opened in GitHub, which was soon be fixed. Another thing we came across when we tested in our Frankfurt region the connection to AWS, it simply didn't work, and that was because of the signature that AWS was requiring. That location was version 4. And unfortunately, Frankfurt and Seoul are the only regions from AWS where version 4 is mandatory. Therefore, that means that with the current version 1.3, you're not able to use that plugin as a Frankfurt region. That's also something that is currently on the work. Then we had some issues regarding renaming with files to special characters. There was also a GitLab issue often open for that. And another thing was renaming of 4 large files. That was something that Earl mentioned. The renaming is basically a two-step process. It means doing a copy of the first object to an object with a new name, and then deleting the old one. And what we came across was a timeout situation, so that at a specific size of an object, it simply didn't work. You get a timeout, and you end up with having 2 objects. One is the new, because under the hood it really worked. And since the delete was not really executed, the old one was there also. And therefore we had some strange things in our buckets happening. And when we tried to clean up some orphan entries which pointed to the S3 bucket, it wasn't possible using IRM --f. So therefore we also opened an issue, but that is already solved. So I checked some. We also found out it did not really work on archive resources. So we had a use case where we have a, let's say, S3 bucket, and in the S3 bucket we have data provided by a sequencing provider, and we were able to register that data, but checksumming itself was not possible at all because it's not supported with compound resources. Good. Yeah, so how do we get the relationship between iRODS and object storage better? Yeah, one thing is iRODS currently relies on POSIX file system, and I would expect if S3 would get the status of a first-class citizen in the iRODS universe, that will get better. So that should be on the list of enhancement for upcoming releases to get rid of that construct with a compound resource. Then during the rename, we ask ourselves how can we avoid such situation in the future, and our suggestion was there might be a reason to decouple the naming in the bucket from the naming in the iRODS catalog. There are certain use cases for that, and the question is, if I rename something in the catalog, do I really do the rename in the file system, or is this not necessary? So that was the basic question that has to be answered. And there will be, in the next version of the iRODS connector, the S3 connector, a parameter where I can switch off this naming persistence. So yeah, since object storage is providing its own capability of doing checksumming, I think it's also a good idea to somehow relate that to the checksum in iRODS. Of course, that is not as easy as it sounds, because I think you need something like a, let's say, custom checksum mechanism that you are able to provide different checksum on different objects depending on the object that you have and on the methodology that the object storage provider is provided. So that's no easy one, but I think it's worth the effort because currently you have to read the data, calculate a checksum compared with the catalog, and that's it. With object storage, it's just a give me a checksum, it's the same, okay. So therefore, that would be a great enhancement, I think. And yeah, the other thing is use more parallel sessions in byte transfer, but I think that's already addressed using that multicard enhancement that Earn provides. Is that right?
It should be. So as long as your files are many megabytes, hundreds of megabytes, you'll have them.
So it's most likely already been covered. Yeah, error handling is something. If you read the link from AWS, the bad thing is if you do a read in a POSIX file system and you get denied or whatever, then you know you're not able to read it. But in S3, the world is a little bit more complex. So there is a something you're not able to read it, but in future you might be, or so therefore the retile mechanism is something that needs to be deeper looked into. That's what my personal assumption was.
I think right now it actually does do retry. If it's a retry, Amazon returns like something retriable there. I think it will retry.
So it already does it.
I believe so.
Yeah, okay, so then just forget my last words. Yeah, and another thing, object storage itself is also capable of storing metadata together with the objects because that's what it's made for. And the big thing is, I think we should get better understanding whether we can utilize or at least bring that together with metadata capabilities that iRODS have. I think there should be some discussion at least if it makes sense and how it makes sense. And yeah, so with version 1.4, things obviously get better. So version 4 signature will be there, and also the decoupling of object names. Also, the renaming issues that I experienced will not be there anymore. Also, multipart, which didn't work before, will be there, and also a lot of new parameters. And so my simple message is, if you want to store objects which are bigger than 5 gig, wait for the next version. That's all. So thanks very much.